Okay, so let's try to code this up. So first we'll declare two variables, okay, to store the length of var1 and var2. So m is equal to length of var1, n is equal to length of var2. Okay, after that we'll declare a dfs function, def dfs, okay, and it will accept two parameters. So one is var1 index and another is var2 index. Okay, now we'll call this function with dfs of m into n. Okay, so we are shifting the index over here. Okay, next what we'll do, like over here we need to write the base case. Okay, as we'll be following recursion first. Okay, so what base cases we can write? So if let's imagine like var1 is empty, right? So in that case we need to copy all the characters from var2 to var1, right? Okay, so let's say we can say, in that case we can say, if var1 index is equal to 0, then we can say return var2 index, right? And if var2 is empty, so if var2 index is equal to 0, then what we can do? So then var2 index is equal to 0, then we need to remove all the characters from var1. So in that case we can return var1 index only. Okay, so first two base cases are done. Next we'll write the two cases. So case 1 is both the letters are same, both the letters at the current index are same. Case 2, both the letters at the current index are not same. Now in case of not same, then we are doing three operations. So it is insert, then delete, insert, delete, and then replace or substitute. Okay, so in case of insert, what we are doing? In case of insert, what we are doing, we are putting a letter from var2 into var1. So in this case var1 index will remain same, but we have taken one letter from var2, right? So in that case it will be var2 index -1. We have to go for next index. Okay, delete, we are removing from, only from var1, right? So in that case the var1 index -1 and var2 index will remain same. Okay, index in var2 will remain same. Now replace, if you are doing replace, so we are putting one letter from we are taking one letter from var2 and replacing one letter in var1. So in this case what will be we have to go for the current for the letter operation for the current letter is done. So then we have to go to next index, so it will be -1. Okay, now both the letters at the current index are same. So in this case what we have to do, we have to go for next index. So basically what we have to do, we have to go for next index. So it will be var1 index -1 and var2 index -1. Okay, so let's write the code for this. We have just written comments for now. Okay, so if we can say if var1 at var1 index -1, as we have shifted the index, as we are taking one index extra, so in that case we need to subtract. So var1 is var1 index -1 is equal to var2 and word2 index minus 1. Okay, so this is first case, okay, case 1. Then what we are doing, we are going for next index. So in this case we can simply call this recursively, and over here we'll subtract minus 1. Hope you're good. Okay, next, a case 2, both the letters at the correct index are not same. So in this case we have to do an else operation. Okay, and for each insert, delete and replace, let's call the function. So before that, what we can do, right, over here we can declare a min distance. I mean, that will be nice actually. Min distance equal to 0, and over here we can put min distance is equal to this one. Okay, next we'll do for this insert. Okay, so insert would be insert of, okay, insert of is equal to what we are doing. So we are going to, word index will remain same and word2 index would be decremented. Then we'll copy this for delete also. Delete ops, what we are doing. So delete ops, we are moving to next index for word1. Okay, then replace ops. So replace ops, what we are doing over here, we are going to next index for both. Okay, so it will be minus 1. word2 index, word1 index, this is fine. And finally we need to calculate the mean distance. So over here we can calculate mean distance is equal to minimum of these 3. So minimum of insert ops, then delete ops, and substitute or replace ops. Okay, so many ops, man. Okay, and then we need to add of 1 for the current operation. Okay, and finally what we can do, so finally on this case 1 and case 2 is over, we can simply return this whatever we have done, return minimum distance. Okay, so you can return the minimum distance. Okay, and we can call this function return dfs. Okay, so if we are, I think we're good over here. Okay, it's passing. Okay, so if you submit this, obviously you'll get TLE. So in this case what we can do, we can let's write the time complexity, space complexity. So over here what we are doing, so we are taking 3 decisions over here, right? So in this case what will be time complexity, it will be exponential. So you can say it will be 3 to the power m, where m is the length of word1. Space complexity would be O of m, because we are using auxiliary access over here. Okay, now if you want to optimize this, then which approach we can take? We can think of taking top down first or memoization first, right? So if you want to do memoization, then we can have a dp table of size m into n. So it will be, we can initialize with -1 star n plus 1. This is for the inner list. Okay, for item in range m plus 1. Okay, because we are shifting the index, that's why I have taken one more extra index over here. Okay, now what we'll do, so first we'll store over here, so min dp of word1 index, not over here, dp of word1 index and word2 index. So first we need to store word2 index is equal to this minimum distance, and if this memoized value is already there, then what we can do, we can simply check whether we have already memoized or not. So in this case, if dp of word1 index and word2 index is not empty, is not -1. So we declare -1 over here, right? Not is equal to -1, then return whatever we stored on this, whatever we memoized. Okay, return dp of index minus dp of word1 index and word2 index. Okay, so hope we are good. Let's try to run this. Okay, passing as well. Let's try to submit this. We're passing as well, 98%. Awesome, man. And what will be the time complexity? Time complexity will be m into n. Space complexity, you are using a 2D list over here, so it will still remain O of will be having O of m into n space complexity, and we are still using an auxiliary stack space. So for that we'll be having O of m like we had before. Okay, now I mean, this is fine. Now how can you remove this auxiliary stack space? Okay, so if you want to remove this auxiliary stack space, then we can go with bottom up or tabulation. So let's try to copy this code over here. So we'll copy this. DFS is needed. I think it's not needed anymore. Okay, goodbye. Then over here we'll initialize with 0. Okay, next we'll copy these two base cases over here. So first we said like if word1 is empty, word1 is empty. So in this case word1 is empty, then we need to copy all the characters from word2, right? So in this case we can say for word2 index in range n plus 1. Okay, so 0 to n plus 1, we can say dp of 0 word2 index, dp of 0 word2 index is equal to word2 index. Okay, what else we can do? This is done. Okay, next we'll copy paste the same thing if word2 is empty. So in this case word1 index, this is n plus 1, and this will come over here, this brother will come over here. Okay, and over here it will be 0 word1 index over here. Okay, so first two base cases are done. Okay, next we need to take care of these two cases over here. Okay, so in this case we will run a loop. So the 0th index for both the word1 and word2 is done, right? So in this case we can start from left to right. So for word1 index in range, word1 index in range 1 to m plus 1, and for word2 index in range 1 to n plus 1. Okay, next what we'll do, we'll copy these cases over here. Okay, so we'll copy this case 1 and case 2. We'll copy over here. Okay, over after copying we need to take care of the integration. So this is fine, I guess. Okay, now over here what we'll say, dp of word1 index word2 index, copy this over here, word1 index over here, and it will be dp of word1 index minus 1, word2 index minus 1. Okay, so first case is done. Then we'll copy this word1 index and word2 index over here. Before this is minimum of word2 index, and over here we'll remove this DFS dp of var1 index minus 1, var2 index minus 1, var2 index, this will remain same, dp of var1 index minus 1, this will be done, and finally we can return dp of m into n. Hope we are good over here. For one, first case is, this is case base case 1, base case 2. We initialize n plus 1, this started from n plus 1, this is m plus 1, this is fine. var1 index, we started from 1 to m plus 1, var2 index 1 to n plus 1, both we are comparing case 1, and we have moved to the next index, else, insert, delete, delete ops, replace ops, okay, and finally we are storing in dp of var1 index, var2 index, minimum of these three operations plus 1, and finally we are returning dp of m into n. Okay, let's try to run this. Range is not defined. Oh, that is spelling. Okay, I think we're good. Okay, so let's try to submit this. Okay, it's passing as well. Okay, so what will be the time complexity? So time complexity would remain same. Space complexity would be O of m into n, because we have removed the extra auxiliary stack space over here. Okay, all right, any other optimizations we can do? Okay, yeah, I think we're fine. Okay, thank you.